Good evening or good morning to everyone, and really welcome to the session, parallel session on peri-urban living labs and geodesign, the Jesus support environment as a tool for co-creation. We are particularly happy to activate this session that is also the presentation of one of the opportunities and result of the Horizon 2020 REPAiR project. Let's start from the identification of some relevant issue that could be considered the opportunity to understand in which way waste flow can be assessed, analyzed, and also identified for select and develop some eco-innovative solution. And it's also interesting because it is activate a methodological approach that where three different opportunities of approaches can interact, starting from the geodesign decision support environment and peri-urban living labs with the life cycle assessment, in order to identify which way we can select waste as resources and also activate a circular also considered the wastegate concept and the wastegate regeneration as a challenge for this REPAiR project, and also considering the opportunities to identify in which way the participants are relevant for the interaction and especially for the construction of a partnership that is a partnership of public, private, and people. So we identified also the opportunity to define a methodological framework where phases, tools, and models interact each one with others, and also where geodesign is the central point and peri-urban living lab are a way to give a real context opportunity to identify a methodological process and activate a decision-making process according to a collaborative perspective. In this interaction, we considered also the opportunity where the geodesign is also the support for an open innovation platform where GDSE is one of our main results. And also it's interesting the activation of different opportunities for different case studies, starting from the main two pilot cases that are related to Naples focus area and Amsterdam focus area. The great challenge is also to identify how it's possible to build a circular landscape, starting from wastegate regeneration, considering flow of waste as a particularly relevant point. We are very honored to have with us Professor Karl Steinitz, that is the author of Geodesign Approach, and also is one of the most relevant professor that worked on this topic and that opened the street to reflection in scientific but also operative consideration. And the session then will work with the presentation of the result of the peri-urban living lab methodology with Anna Tademo and Libera Menta of the University of Naples Federico II. And then there will be the section of DGDSE functionality. This also considered as a platform, and starting from the result that in REPAiR project we obtained with the presentation of Gustavo Archigeas, that is one of the person that worked for geodesign platform in very relevant way. And then we have the discussion, a panel discussion with some relevant participants that are outside of the REPAiR project, as Michele Campagna of the University of Cagliari, Giulia Lucertini of the University of Venice, and also Dirk Washers that worked for some other international relevant project of research. So thank you so much for your cooperation, and I give the floor to Professor Steinitz, and we are very honored to have him with us. Thank you.
You have to unmute you. Carl?
Doesn't work, your phone.
You need to unmute. No, it's on the screen. The bottom of the screen, the second button.
Now can you hear me?
Yes.
Okay, so now I go to share the screen. I go to, what happened then? Okay. I go to application. This is me. I share the screen. That's not it. I go there. Can you see my screen now?
Yes.
You see my first?
No, now we see your email.
Then I have to go back. Just a minute. I'm going to stop sharing. I'm sorry for this, but this is really just causing me trouble. Can you still hear me?
Yes.
Just a second.
No worries.
There it is. Okay, now share screen, go to application. Why isn't
PowerPoint?
Go to application. I'm sorry, but I don't see my application. My computer is on, and it's not showing. I'm not seeing my slides on my computer when I go to application. I don't know quite what to do.
Can you open out the PowerPoint again? Make it.
Okay, my PowerPoint is now on.
Okay.
I'm seeing my first slides and all of my slides.
Okay, then you should go to share again.
But I can't. Just a minute, I have to minimize this and go to share again.
Yeah.
There it is. Oh, there it is. There it is. Share. It didn't work.
No, it does. It does. It does. And now you go to full screen on your
full screen. Full screen.
Yes. One more.
Oh, very good. Okay. Well, first of all, thank you for inviting me. It's very strange. I'm going to be talking about peri-urban, but not waste. And I must say that I know that my framework for geodesign has been used in all kinds of special fields, which I'm not part of. But what I'm going to do today is talk about what I really think the real problems and needs are. And they're different. They're different from the way the morning session presented itself. I'm going to talk about why geodesign, in my view, is important for important problems, and why negotiation is the best design tool, not modeling. I don't believe that models will provide policies and projects for long-term major change. I think politics is the necessary piece. There's a subtext. The subtitle is on the merits of applying minimal relevant data and when seeking a strategic solution to a complex and relatively unpredictable problem. What I saw this morning, to be blunt, and I'm telling you what I think, was big data applied to the management of an existing and presumed predictable problem. In other words, I believe in Costanza's law, Robert Costanza, a very world-famous environmental ecologist. And what he said is, the more precise you are, the more wrong you are. Anybody who is very precise has a half-life of their analysis that's maybe 10 minutes. And if the real problem is looking 2 generations ahead to the year 2050, you know that your model is wrong when it's based on past data. If you believe that you're seeking a strategic solution to a complicated and relatively unpredictable problem. Furthermore, nobody designs waste without designing all the other systems, and you don't know how the other systems impact on your waste. And without knowing that, your model has to be wrong in the way it's applied. And so I'm interested in the opposite approach to what I saw this morning. I want to use the smallest amount of data. And by the way, at CASA at UCL, I'm surrounded by PhDs and postdocs working on big data. They're doing what you're doing, but they can't make a plan for the year 2050. And that's what I think the problem is. Because I think the end game of our work usually requires a purposely designed plan for future action. And future is not tomorrow morning to me. And this is normally and necessarily a political process. To me, the generic problem is how do we organize and conduct the very beginning, and strategic, not tactical and not managerial, but the strategic changes of designing for longer-term change in a large, multi-system, multi-client, relatively unpredictable and contentious context, and one which should not become a zero-sum game. And this is frequently the situation for important and complicated projects and studies. This is what I think the problem is. This is from Xu and others, proceeding from the National Academy of Sciences of the United States. The problem is that between now and 50 years from now, the areas in red will become unsuitable for human habitation. And according to this study, if there's a 3 °C climate change, 3.5 billion people will have to move. And even if it's only 1 point, then 1.5 billion people, 13% of the global population, will move between now and 50 years from now. So how can you assume that Amsterdam is going to be the same, or the Netherlands, or Europe, or the world? And every continent will have these pressures. And walls won't change it. These pressures will exist. Feeding 9 billion people by 2050 will require a 60% increase in agricultural production and a 15% increase, but a 3-degree change in Celsius will reduce crops in the red areas 50%. Whereas Canada, Soviet Union, Sweden, Finland, Chile, and parts of Brazil will become more productive, doubling. But those people in the red areas aren't going to have food. And the water supply in those areas in brown will be no water. The brown is no water for 12 months for the entire year. None, except salination. And that may be out of the question. And even if you plant 1 trillion trees, you're going to go up 1.5 degrees Celsius. And that's what the problem is. And the only solution that I can think of, is to teach 10,000 people in the next 5 years how to deal with geodesign at the local to global to local level. And so I'm not spending my time on doing fundamental research. I'm spending my time and some of McKaylee's time on how do you teach 10,000 people in the next 5 years to think about geodesign on global scale issues for the next 30 years. These are important problems. And frequently there's little time for decision. People have different interests and priorities. Each needs legitimacy. And geodesign does not normally produce a final product, in my opinion. In my opinion, it's most likely to be useful at the beginning of thinking about what to do, about the strategy of what to do. It's complicated. There are huge uncertainties. There are multiple geographic scopes, complex content systems which vary by size and location. There are many change requirements. Waste management is only one of them. Circular economy is only one of them. Geodesign methods do not scale. Don't believe that your models can be used at the global scale and at the local scale. It's not true. And they never repeat exactly. A model for Amsterdam is not the same as a model for Ljubljana or Maribor. They should fit the context. And therefore, geodesign and its technical support has to be flexible, iterative, understandable, and fast. In other words, we need to make decisions on what we know, and we can't wait for the primary research. Geodesign has to be dynamic. Change is a relational synthesis in space and time of sets of policies and projects, and the sequence matters. I need to make the housing development before you have the waste model. I don't want the waste model necessarily before I have the housing model. Design should be assessed and iteratively improved, knowing that any change changes all the systems. We've already done many experiments. The first plan is never the best plan. It's usually the fourth or fifth. Therefore, a primary aim of geodesign is to rapidly move from infinite possible designs towards a socially, environmentally, and economically feasible one. The end game of geodesign has to support informed negotiation. At the local short-term level, a model like we saw this morning is very useful. In the long term, it's not very useful. Geodesign is likely to be collaborative. Therefore, all aspects of geodesign support must be easily learned, easily used, easily communicated to the Prime Minister, possibly, and most importantly, the language of geodesign must be easily understood by all. Geodesign is a collaborative, social, political process of design. The design will emerge. This is important. In other words, when lots of people are working together, nobody's design will happen. The design will emerge. You know that I've written a book called The Framework for Geodesign, but I've used this framework for almost 50 years. It was first published in 1990 in a paper. The fact is, it works. And by the way, it's purposeful. It's not the framework for geodesign, it's a framework for geodesign, because there are others. Mine happens to be a workable one that lots of people are using, more than any other one. It's not the only one. The thing that makes it useful is any framework, and that is if you go back. In its application, never. It has a workflow. It has a workflow that I'm not going to do, except I'm going to show an example of the workflow. Now, 2 years ago, at the 9th Geodesign Summit meeting in California, I proposed to Tom Fisher and Brian Orland in geodesign. And within 9 months, by word of mouth, no advertising, we had 90 universities. We are now about 160 university-based teams in about 55 countries, and we've completed 96 projects in geodesign. They all share an agreement. Everybody has agreed that we would study 10 systems, 8 of which are required. In every design, 8 of them are required. Water, agriculture, green infrastructure, energy, transportation, industry and commerce, institutions, housing, and then 2 are optional, and there's a big list. And these colors are the internationally most used colors for them. Europe has its own system, but the rest of the world does not. And the rest of the world, most people use these kinds of colors. We agreed that everybody would work at least in 2 scales, and that the scales would be standard and geometrically increasing. The smallest is 0.5 kilometer square. The biggest is the Nile Delta, so it's huge. We all agreed that we would use 3 time stages, 2020 or later, next year, 2035 and 2050, and three scenarios related to the adoption of early adoption, late adoption, and non-adoption of any information. In other words, this team of scenario A would accept the models we saw this morning and implement immediately a circular waste economy. The non-adopter would never adopt a circular waste economy. What difference does it make, is the question. And finally, everybody would assess their designs by the UN Sustainable Development Goals. We're operating to the year 2050 with 12 global assumptions. The World Bank uses many of these. Other institutions that look forward use these assumptions. These are all downloadable PowerPoints from the website. One of them is freshwater scarcity and where it will be. We researched innovations that are expected by 2035 and 2050. We have 157 of them spread across the systems. We do not have them with waste as a separate system. We should, we don't. We have standard formats for presenting projects. There are the 3 scenarios for the growth of the United Arab Emirates, the city of Al Ain, and there's downtown Minneapolis in the United States. There are the SDG assessments of these designs. We've got 96 comparable projects, and we have compared them. We've written the first book from the first series. They're all on the website. And this is the most important thing that we learned from our first 50 projects. One of them is that the most important systems are water, broadly defined green infrastructure, and housing, agriculture, and energy. But this is the important thing, that different climate zones, economic zones, and cultural geographies define these with different levels of importance. The lesson is very important. The lesson is, the longer you're looking in the future, the less one model in one structure works. Not the more, but the less. We have been teaching faculty. In other words, I'm now too old to teach students. I don't teach students anymore. I haven't for 12 years. But for years, I've been teaching workshops for teachers, for faculty, on how to do this. And in June, Michele Campagna, who's in, and I taught one workshop for North and South America faculty, one for Europe and Asia, one for Europe and Africa, one for Europe and Asia. And the interesting thing is that everybody who was in the workshop collaborated remotely using Zoom. I'm now going to show you a peri-urban project from last week where I, Michele, and Rishi Bilal did a workshop with 30 faculty and PhD students who teach. And we worked on a city in Africa with the African conditions. We were teaching, we were teaching the growth of a city that's about 500,000, which is like Port Elizabeth, South Africa, Kumasi in Kenya, Apapa in Nigeria. And we were focusing on synthesis. We were focusing on the what, where, and when, and how we can do this. And this is a workshop that over 3 days and 11 hours was working together. We decided we would have people with us for 11, maybe 12 hours, and no more. We were using GeoDesign Hub, which embeds the workflow that's in my framework book, but it's invented all kinds of things in addition. And it's a program that is free to use. if you're a member of the collaboration. Otherwise, it's a very efficient program to rent, and it works really well for the level of work that we're doing. It requires you to have a decision model for the systems, a study area, requirements, evaluations that are in no more than 5 levels. Let me explain this very importantly. In order for everybody to understand each other, we have to speak the same language. And the language is, red means it's existing, leave it alone. Yellow means it's not appropriate for what you want to do. Light green means you can do it, but it's not serviced for use. It's capable, but not suitable. Middle green means it's suitable, but it's serviced, but nobody really wants it. Dark green means it's capable, it's suitable, and there's a market for that area. And each of the systems is in the same language. So your energy, your waste, if it was a system, would have to be in these colors, because I want to compare your system with my system. And if I don't use the same color code, I can't do that. Then there are some simple models. What does one system do to another system? And then there's a budget and a cost model where we need numbers. What does housing cost? What does roads cost? What does planting trees cost? And we have numbers for that all over the world. Then we can basically develop diagrams in color code, make designs, compare designs, negotiate designs, put our projects and policies and timelines. We can show it in 3D. We can calculate the budget. We can do all kinds of things. And any single piece of this can change during the course of a project. It's dynamic. The 2 ways we work is we have our scenarios. We make teams for the different scenarios. Sometimes we have more than one team. They have to negotiate a design, and they assess the design. Or the same way, except they're asked to make a recommendation, which means deciding between immediate adoption, late adoption, and not an adoption, and making then a final design and making an assessment. We were trying to do the latter with this group of people. 2 of them, a former student of mine is professor at Jomo Kenyatta University in Nairobi, and Maimuna Munari from Zaire University in Nigeria, selected from the 157 those that they thought would be at 2035, like water retention, controlled environment, organic agriculture, solar crop pumps, connecting linear parks, etc., and those which would come in 2035, like tidal power, roads that are energy sources themselves, etc. These are all downloadable on the internet. I'm not going to spend time on them. Then we basically made believe, listen to me carefully, because this is for all, we had 6 countries and 11 universities present. So we didn't want to study one place. So we took Cagliari, this is metropolitan Cagliari, and we said, let's make believe it's in Africa. Let's just make believe it's in Africa. It's roughly 500,000 people. It's going to double between now and 2050. So between 2020 and 2030, these are the systems, and this is how much we need, except transport and green infrastructure can have as much as they want. A fourth of these people will be refugees from other parts of Africa who are different from the people who are there now. The same happens between 2035 and 50. So you have to plan this much change in this study area. Those are the amounts. That's the language that we use. Everything is in 5 levels with different colors. And that's because the Prime Minister can understand that. And he doesn't understand your language at the research level. So each of these systems has sites that are existing in red, the best sites which are available in dark green, light green is possible, yellow is not appropriate. It's steep, etc. And there are innovations which you either do or you do not use. And there are 10 of them, all in the same language. They can all be overlain. And by the way, they can be all updated at any time as you make a design. The sessions are 2 hours on Monday, 4.5 hours plus a break on Wednesday, and 2 hours on Thursday. We had 35 people, and we broke them into 6 teams, as mixed as they could. These people, this is Ethiopia, Nigeria, Italy, Kenya, Nigeria, etc. They're all African, or they're all working in Africa. And there they are. Everybody's in a different place. We're on Zoom, which, by the way, is really easy to do this work on. And we start out with existing conditions. We're going to have 2 teams on 1935 and 6 designs for 2050. And the red ones then have to be negotiated to a final design. Michele and I defined the problem. So we went through the framework this way up to this point. And this is now the first day. Everybody is here. We've explained the problem. We're showing them what we're going to do. They're going to make a first design. It's not going to be good enough. They're going to make a second design, changing scale as necessary, and it is going to be good enough. It's going to be 2035. They're then going to update the data. They're going to basically say, all right, we've built 2035, update the data, update the process model, update the evaluation model, and make a 2050 design. And it's not going to be good enough. And you're going to do it again, and then it's good enough. And then you're going to take the other 2050 design and negotiate it. And either we're going to stop if we don't have enough time, or we're going to negotiate to a final design. And so the first thing we did after the first hour is we taught everybody how to make a diagram of a project or a policy, which is hatched, or we imported, this is the real ring road design for Pagliari, simply imported from GIS. There's no reason you have to draw it. And not only that, you can draw the policy in relationship to another project, like new housing. Now let's design a housing policy in an existing area. And we taught everybody how to do that. And then we said, as homework, everybody in every team has to make at least 3 diagrams, and each team has to produce at least 1 diagram for each system. So on the second day, we had about 120 diagrams. Every diagram has a size, it has a label, and if you want it in your design, you simply press this button and it goes into the design. A hatched diagram is a policy, a solid color is a project which gets built. It took 1 hour for the teams to make their decision model, and as you can see, the early teams had their open space and water and agriculture as the most important thing. But the non-innovating teams had housing as their first thing. That's really interesting. That if you're thinking about tomorrow morning, housing is more important. If you're thinking about 30 years from now, you realize that water and food are the most important. So it took them 1 hour to make the first design, and it was a terrible design. We looked at the impacts. This team happened to do very well. Purple means in the scale, it's very good site, but you can see right here, they have a problem, and in their second design, they'll simply change the design. They'll edit the project or they'll eliminate the project. So they made a second design and they made a third design, and this is the final 2050 design. I'm sorry, this is 2035, and they carried forward to 2050. They made their second set of designs, and these are much better. Then they updated the evaluations. And for example, you can see here, look at the last one. Look at the green infrastructure. Look at this last slide. This is 2035. This is by 2035, you no longer can use these lands for green infrastructure. They're now being used for other things. So it's changed. And now they're finished at the end of the second day. At the end of the second day, they had made, after 4 hours, 2 designs for 2035 and 2 designs for 2050. But we had 6 of them. So on the third day, we used the most important tools at all. This is a tool called combined analysis. This puts all 6 designs for 2050 on top of each other, all of them. All of them. And what you can see is several trends. You can see there's a trend to build everything in this inner zone. And the system has to expand over the whole study area. This is a very, very flexible technique where you can look at one system at a time. We understood that most of the designs used these systems, but most of the argument was about housing and conservation, green infrastructure and housing, which were very important. There was very little agreement on. So we had to set up an organized negotiation where pairs of teams could compare their designs and compare the diagrams in them and negotiate a final design. This is the single most important tool for geodesign in Geodesign Hub software, because this graph of all the projects is alive. If I press this button, that diagram will go into the design. If I press this button, this diagram will disappear from the design immediately. So during the discussion, I was managing this screen and I was listening to the discussion. And when they agreed on what to do, I made this design, but anybody could have done it. So by the end of the second day, by the end of the first day, we had these 6 designs, and you can see, this is the early adopter. The first thing they did was agriculture and green infrastructure and some housing, mainly high density housing. And the high density for refugees was here. The city is here. Then they had to build much more. And they said, we're not going to anymore build this refugee housing. We're going to build lower density sites and services housing. These people originally started with sites and servicing housing for their refugees. It was here. But then they decided to remove that and to build it closer to the cities, because this group, the non-adopters, had immediately started building the sites and services here. And it worked. It was a much better solution, rather than separating people in a special place. So this non-adopter team was very influential in this group. They worked together. They were very influential, and they carried that forward, but so did these people adopting some of their designs. Then we had to negotiate these 3 designs, and this is the final design. This is the final design, and it was done at about 2-hour level, at about the 2-hour level on the third day, after about 11 hours of joint work and 1 hour or 2 hours of independent work. Now let's look at the final design. This was the original problem. This is what they had to put in the 2050 design. This is what they put in the design. This is the final project. They've got more single-family housing and less. They've got more single-family housing and less high-density housing, because the high-density housing didn't work as well. It had to be relatively high density, but on the ground housing. This is it in context. This is its impact statement. It's pretty good. It's got good sites, good locations. These are the projects and policies that are members of the design, and each of them has a cost. Each of them has a town line. One of them could be mixed economy. One of them could be waste management. It can be assessed by the SDGs, by judgment, not yet by a model. It can now update to 2050. So we can continue to the year 2000 if we wanted to. So this is what happened in 11 hours. We started with the existing conditions. The design evolved. It evolved. There was no design that came out of the workshop by agreement. The designs independently evolved and then were negotiated into a design which everybody in the workshop said was better than anything they could do by themselves. And these are all faculty members, our colleagues in African universities, most of whom were taught in Africa, but quite a few of them were not. So this is our workshop. These are the people who did it. I invite any of you, all of you, please join the collaboration. We don't tell people how to work. We tell them what the structure of the problem when it's finished needs to be. We're governed by global projects, becoming local, being tested and varied locally, and becoming global. And we are very seriously designing and implementing a technology that can move from the very local to the global and back. This happens to be Slovenia, looking at Ljubljana, where the Ljubljana School of Biotechnics is now doing a national, a regional, and a local study at the same time in this language as a test case for the collaboration. I invite you all to join us. It will not change what you're doing, but it'll organize it so that it can be compared globally with anybody else who is using the same language. Thank you. I'm finished.
Really thank you, Professor Steins, for your very inspiring that opened our reflection and also started with some methodological interesting application that could be useful also for our next research, we hope.
Let me say something in 10 seconds. I want to thank Michele, whose real work in the real life is this place, but now it's a city in Africa, temporarily.
It is. Really, thank you. Now I give the floor to Anna Tademo and Libera Menta of the University of Naples Federico II, Department of Architecture, where they introduce the methodology related to co-creation in Periurban Living Lab that is connected with GDSE that we will see after. Thank you, Annie and Libera.
Thank you, Maria. And to share my video, I need to ask Karl Steinitz, please, to unshare your video.
I see it. It's not allowing me to do. How do is my video still being seen? If it is, I'm going to leave. I'm going to leave and come back. I hope I can do this. I'm going to leave.
Okay, now I can share, so I think, okay. Hello everyone, I'm Anna Tademo, and I will present this co-creation methodology in Pulse. REPAiR has implemented living labs for 6 European peri-urban areas, where key actors, scientists and students collaboratively generated new ideas and strategies for the development of circular economy, by first generating inputs for the development of the 6 models that build the GDSE. The key to successfully using the Living Lab approach has been the choice of different study areas to be representative for most European countries and to detect limits of transferability. Pools have been carried out simultaneously in 2 pilot studies, Naples and Amsterdam, because Naples case focused on territorial and landscape questions, while Amsterdam case focused on waste and resource optimization. The follow-up studies included both challenges and were based in Belgium, Germany, Hungary, and Poland. Across Europe, living labs have been recognized as successful instruments for speeding up the innovation process, co-creating and improving innovative ideas. Living Labs definition and associated concept became REPAiR common environment, physical and virtual, to encourage a mutual and consistent interaction among different fields of knowledge. A living lab is, in our opinion, a systematic approach that integrates research and innovation by collaborating with multiple stakeholders, public, private, people partnerships, to co-create, develop and validate new products, services, business and technologies for sustainable value in territorial ecosystems in which the user is actively involved. The human is recognized as a source of innovation and not just as a user or consumer in a narrow sense. One of the specific innovation is, in comparison to other forms of participatory process, to put participatory process into real context, giving space to co-creation activities. Co-creation is the process that leads to a product or a service, as well as to ideas, concepts, and strategies, as the result of a cooperation between end users and other relevant stakeholders that work in this common environment. REPAiR team combined the concept of eco-innovation with the contextual knowledge developed in Pulse, eventually defining it as a place-based process and systemic tool for peri-urban areas. An eco-innovative strategy for REPAiR is an alternative course of action aimed at addressing both the objectives and challenges identified within a pool and develop a more circular economy in peri-urban areas. The strategy can be composed of a systemic integration of 2 or more elementary actions, eco-innovative solutions, interpreted as responses to case-specific problems. REPAiR innovates the living lab methodology called FormIT from Professor Stalbros, considering that knowledge increases through iterative interactions between phases and people with diverse competencies and perspectives. REPAiR started from an evolution of this FormIT spiral, elaborated by Professor Maria Cerreta as tutor of Simona Panaro PhD dissertation, combined with the 4CO model, co-design, co-decide, co-produce, and co-evaluate. Then REPAiR Pulse has these main iterative cycles: co-design, co-production, and co-decision. In each cycle, there are 3 phases: appreciate opportunities, design, and co-evaluate. Before and after the 3 main cycles, we have co-exploring and co-governance. Central aspects for developing a pool are regional context and place specificity, data, spatial models, and availability of information on stakeholders. This research places this framework in relation with the geodesign approach. Based on 6 representation modes, geodesign questions are combined with the phases of the pools, providing a methodological structure to the activities. In Living Lab hybrid methodology, co-creation is a transversal concept that passes through and supports the spiral in its different cycles. In REPAiR, the interaction between Living Lab and geodesign as a co-creation context as common framework. 4 application points have been set as dedicated to the activities of corresponding pool phases, establishing related topics that what the outputs of using the GDSC in the specific workshops are. The pool co-creation approach has grown and developed through a range of variations in different settings, applied in universities, community action groups, and as a tool for local and regional policies. Based on the pilot cases of Amsterdam and Naples, a preliminary structure was developed and presented, constituted by the iterations of design studios, coinciding with the GDSC testing, knowledge transfer events, and stakeholder participation workshops, in which the results of student activities and research from other consortium members have been integrated. Then, in follow-up cases, the methodology has been further refined in a real-life and learning by doing environment. Then on the phases, I leave the floor to Libera Menta.
Hi everybody, now we will go step by step through the phases of a living lab. So the first phase is the co-exploring phase. In the co-exploring phase, a common understanding of the territory is developed with the collaboration of all the researchers, stakeholders, and experts. Key resource flows are selected through the definition and mapping of material flows and waste management system. The thematization of the main challenges and problems and objectives is eventually conducted. The co-exploring phase deals with the representation and process model of the geodesign framework. In particular, this phase is aimed at developing an integrated understanding of the study areas with reference to material and territorial resources. Thus, waste cycles and wastegapes are selected at this stage. The aim is to move towards a more circular city where there is not anymore land consumption and where pollution and land degradation are reduced in favor to healthy urban metabolisms. The collaboration of all stakeholders, which differ case by case, is crucial at this stage. Stakeholder needs, challenges, problems, and objectives are also defined now. So in this way, the sociocultural values of the context are preserved and valorized. And the thematization of the main challenges, problems, and objectives conducted in this first stage has been done with the help of predefined design tools, such as the challenge trees, which have been completed during pool workshops. Common activities, such as field works, as you can see in these pictures, have been also helpful to develop a shared understanding of the spatial characteristics of the 6 peri-urban areas investigated, and of the material and territorial resources of the case study areas. In this first stage, all the boundaries of the different deepening levels have been defined, and thus region, focus, and sample areas have been mapped within all the regions. Thus, a complete mapping exercise to analyze and interpret the case study areas, called spatial analysis, has been carried out by another work package, so the work package 3, which worked in strict collaboration with work package 5. So a work through different scales has been done in order to get the complexity of the 6 peri-urban areas. In the co-exploring phase, wastegapes are understood and mapped. Wastegapes are defined in REPAiR as wasted territorial resources which have the potentiality to be re-inputted in the urban metabolic flows towards a more circular economy. Wastegapes have been mapped through an iterative process. Maps produced by researchers have been verified in pool workshops with the collaborative work of local stakeholders, and then the maps have been adjusted according to the feedback received. Among the wastegapes mapped, there are, for example, polluted and abandoned soils, but also all the infrastructure for the waste management, which do not build healthy relationship with the environment. Moreover, in this co-exploring phase, the key resource flows have been also defined for each case through the mapping of material flows and waste management systems. So we go to the second phase, which is the co-design. Within this phase, local teams develop the capacity to design eco-innovative solutions and strategies. To achieve this goal, academic activities like workshops and seminars, as well as pool meetings, are carried out. Research and experiments are then conducted to assess the status quo, further identifying specific challenges and problems in order to define eco-innovative solutions and their functioning. The co-design phase is related to the evaluation and change models, and specifically change model is dealing with the possibilities for modifying the status quo. Then it is the core of the work package 5 of REPAiR. The main activities developed in this phase have been the assessment of the status quo, the identification of specific challenges and problems, and the definition and functioning of the eco-innovative solution. So we answer to the question, how does an innovative solution work? So solutions and strategies have been co-designed thanks to academic activities, such as students' workshops. As you can see, this is in Hamburg in this picture, but as well as through design workshop with all stakeholders in the pools, in the local pools. So different local stakeholders helped to identify the basic needs that the solution or the strategy must have to create innovation. In the co-design phase, the 6 cases focusing on prioritizing problems and objectives, and they focused on the development of initial ideas to be put into solutions. In the pool workshops, first ideas on eco-innovative solutions to improve the capacity of urban environment to deal with the future resource management challenges have been schematized in solution posters. So they have been discussed among different stakeholders and users, which were able to share their competencies and visions of the future of their peri-urban areas. Then we go to phase 3, that is the co-production phase, in which local teams develop a catalog of eco-innovative solutions which are specific for each case study. In addition, they check the proposed eco-innovative solution and strategies feasibility using the knowledge coming from various and specific disciplines by deepening the understanding and development of solutions and strategies. This phase is crucial for the transition toward more circular models in peri-urban areas and for boosting the innovation process. Co-production is related to the change model, of the geodesign framework. And here we have just an overview of all the eco-innovative solutions produced in REPAiR, which are about 100. If we go further in the slide, we can see summarize the iterative process followed in the pilot case of Naples and how the 3 eco-innovative solutions developed are applied in territorial strategies. We can go on in the next step, which is the co-decision phase, in which local research teams and stakeholders explore the opportunities to draw public attention to the eco-innovative solution and eventually to understand chances for influencing the decision-making process. Eventually, if the local condition allows, the design of eco-innovative solution can become a form of negotiation at the local, regional, and even national level in each of the case study areas. The ultimate goal becomes to trigger future local development and influence the decision-making process through co-creation. Then we can see that co-decision phase is related to the impact and decision model of the geodesign framework. In the co-decision phase, the feasibility of eco-innovative solutions and strategies is tested not only in spatial terms as in phase 3, but also within the regional public programs and urban planning policies. In this phase, it is investigated which are the most interesting solutions to be implemented and how to define the strategies for implementing them. So we can say that REPAiR has been having several tangible impacts by applying its findings in policy documents in order to achieve an improved knowledge of site-specific constraints and opportunities and towards a more circular economy within regions, also through the regeneration of wastegapes. In this way, thanks to REPAiR, the case study partners have been involved in further projects. Finally, the last phase is co-governance, this phase is what happens actually after the REPAiR project. So how the different cases will implement REPAiR fundings in their future projects. And so this happens out of the REPAiR scope. This phase is about delivering decision-making models based on co-creation and making them transferable to further cases. And co-governance is related to the decision model of the geodesign framework. This last phase of the project is also related to the release of the online handbook of eco-innovative solution, which you can all access via the website, and which has the aim to help decision makers to actually move towards circular futures. So you can see from this graphic that the solutions are organized both in the online catalog, but also in the exhibition which Ariane introduced before, either per flow, as indicated in the top right of this slide, or per case, as you can see in these small squares, by color. So below you can see instead how you can search for a solution in our website. So there is a search engine that you can use for searching solution. Then there are some examples of innovative solution here about the organic waste, which is interesting for all the cases. And finally, we have a slide with some territorial visions developed by our students in Naples. And we can say that the decision to take about which eco-innovative solution or strategy to implement in each case study is really site-specific, and it is up to the local decision makers. So this step falls actually outside of the REPAiR framework and scope, but REPAiR can have impact on this stage too. Okay, that's it.
Thank you so much, Olivia and Annie. And now the floor is for Gustavo Archinegas of the GeoCall, but also of the TU Delft University, that introduced the GDSE functionality and the result from the different cases that we faced in the REPAiR project. Thank you so much, Gustavo.
Thank you, Maria. Annie, did you stop sharing your screen?
I already did. Maybe I can go out.
Okay, it's visible now? Yeah, do you see my presentation? Yes?
Yes, yes.
Yes, we see it, Gustavo.
Okay. Okay, just 1 second. Okay. Hello, everyone. My name is Gustavo Arciniegas, representing GeoCall, and I am going to show you the main functionalities of the Geodesign Decision Support Environment, or GDSE, together with some results from the 6 case studies of REPAiR. This presentation is divided into 6 parts. In the first part, I briefly introduce the GDSE and its main steps. The second part deals with the first GDSE step called study area. The third part deals with the second step called status quo. The fourth part is about the GDSE step called targets. The fifth part is about how the GDSE is used to support the co-creation of circular economy strategies. And in the sixth part, I will show you how the GDSE compares circular economy strategies with some examples from the 6 case studies. Let's talk now about the GDSE in the REPAiR project context. The Geodesign Decision Support Environment, or GDSE, is the core tool of the REPAiR projects. The GDSE is an online tool that runs on a web server, is accessible by users via a web browser, supports the geodesign iterative process in living labs, and is used at 4 application points according to the peri-urban living lab methodology just presented earlier by Libera and Annie. Here we see on the left the geodesign methodology with 6 questions and the models used to address the questions as presented by Carl Steinitz. In the middle, we see the 5 phases of a peri-urban living lab, as recently explained by Libera and Annie. And on the right, we see how REPAiR uses to define how these phases are supported with the GDSE. And they are called the 4 GDSE application points. The GDSE supports the co-creation. Excuse me 1 second. GDSE supports the co-creation of strategies for a more circular economy. This is a screenshot. Oh, sorry. This is a screenshot of Now, let's see how we develop a joint understanding of the study area. The first step of the study area contains 4 side menus that together describe the study area. The first step, Maps, shows the focus area and relevant maps related to resource and waste management. Second menu shows the stakeholders involved. And key flows are also defined on which the GDSC workshops are focused on. Users can define their study area using external web mapping services as well as individual layer files, for example, containing the data collection on how the status quo situation and upcoming future developments. The second step, status quo, aims at developing a joint understanding of the flows of materials and waste between the different activities in the study area. It also looks on the flows going into the study area or leaving it for other regions, countries, or other parts of the world. The second step, status quo, contains 5 menus that aim to describe the key flows of materials and waste relevant to the study area. The first menu, flows, and shows the key flows for the focus area. The second menu, flow assessment, defines flow indicators for assessments of strategies. The third menu describes relevant wastegapes in the study area. The fourth menu describes the sustainability assessment framework. The fifth menu lists the circular economy objectives set by stakeholders. But now, how are flows of resources represented? Yearly household and industrial waste data is gathered, geocoded, and coupled with European activity data. The result is a point cloud of actors with attributes for type of waste generator, for example, name and location of the company, and waste collector, for example, name and location of waste treatment, and the type of waste treatment. Activity-based material flow analysis is used to analyze and visualize this point data up to the level of individual materials. Flows are visualized in 2 interlinked ways, as a Sankey diagram, here on the left, showing activities, materials involved, and flow rates. Flow direction is visualized from left to right. And upon selection of a flow on the Sankey diagram, as an animated flow on the map, see here on the right. Thickness of flow lines indicate relative flow ratios. Both Sankey diagram and flow map are linked. Here we see an animated flow map on the GDSC step status quo. 4 flows are selected on the Sankey diagram on the left and mapped out on the right panel on the flow map. The flow map shows the directions of the flows, which are determined depending on whether the actor is categorized at the start or end of a flow. By hovering your mouse on a flow on the left, flow characteristics such as start actor, end actor, material composition, treatment type are displayed. Mouse hovering can also be done on flows on the flow map. For example, the orange flow shows an actor, company or household, transporting an amount of tons of waste per year to an incineration facility where the waste will be further processed. This is an example of a flow view involving restaurants, the waste produced in them, and the waste management facilities involved. The flows on the left are color-coded to portray the various actors. Flows on the right panel map are color-coded similarly to match those colors on the Sankey diagram. This animation shows a number of actors and the flows between them now portrayed at material level. The legend on the bottom right corner seen here is interactive and allows users to toggle flows of different materials on and off. I will now show you visualizations of key flows of materials and waste for the 6 REPAiR cases. We start with Amsterdam in the Netherlands. This flow view shows organic waste of type oils and fats portrayed at the material level. Notice how some flows end very far away from the city itself. This flow view shows organic waste showing material composition for the metropolitan area of Naples, Italy. Notice the dramatic extent of some outgoing flows. This flow view shows collected organic waste at actor level for the region of Flanders, Belgium, spanning the 2 municipalities of Ghent and Westerbergen. For Hamburg, Germany, this flow map shows the amount of bio-waste going to the incinerator, east-south, which is much higher than the composting plant north. Actors on flows are aggregated spatially, which is reflected by the encircled number at each flow. The metropolitan area of Łódź in Poland encompasses 8 municipalities. Here we see a flow map showing vegetable, fruit, and garden waste, and displaying 3 types of this waste and aggregated spatially for actors. For the case of Pest in Hungary, food waste from restaurants constituted a core flow in the Living Lab. Here we see a flow view of this waste at actor level, where all flows start in Pest and end outside, some even as far as in Budapest. In the next step, called targets, participants of a workshop split into small groups and agree each to a ranking of the circular economy goals for their area. Here we see an actual photo of a peri-urban living lab session with 3 small groups, each working on the GDSE touch table combination, here highlighted in light blue. Each small group works in the GDSE to rank their circular economy goals and connect them with numeric goals. This is a screenshot of the step targets. It shows a list of boxes with circular economy objectives for the study area. To rank a circular economy goal in the GDSE, the participants select a goal box and drag it to a desired rank until the final rank is achieved. And this process is followed for all objectives until the final rank is arrived to. How to set targets using the GDSE? The stakeholders set the circular economy targets that they will try to meet by means of their waste management strategies. For example, here we see stakeholders trying to increase separation and collection rate for households by decreasing food waste produced by inhabitants by 50%. The 4th step, strategy, helps stakeholders co-develop eco-innovative strategies for the city and metropolitan area. But first, let's remember what a strategy is. An eco-innovative strategy consists of the following elements: 1 or more eco-innovative solutions, implementation locations or areas of these specific solutions, 1 or more stakeholders to be involved in these implementations after a project, a number of actors, companies, households affected by the value chains of the solutions in the strategies. A strategy is a proposed combination of solutions implemented in specific areas by specific stakeholders. In the GDSE, the first menu, Solutions, contains the solutions available for the case study, which have been developed by researchers of the Living Lab based on the circular economy goals of the city set earlier. The stakeholders use the GDSE to select from these existing solutions and draw implementations of these solutions at desired spots or locations in the study area. As indicated earlier by Alex and Annie and Libera, REPAiR has developed around 100 eco-innovative solutions that are available for this process. For example, here we see solution BioBean, which transforms coffee grounds into renewable energy. And this solution is selected now. This tab within the selection shows a description of the selected solution. The next tab shows 2 schemes: the current process of coffee grounds waste and the process proposed in the solution. The current process here on the left is linear and finishes at disposal and perhaps a landfill or incineration plant. The proposed process here on the right follows a more circular path in which the coffee grounds are collected, transported, processed, and turned into renewable energy. We see here how solution BioBean is selected and added to our strategy in the GDSE. After choosing the solution, members of the small group indicate which stakeholders should be involved in the development of the solutions for the metropolitan area. Next, participants set a desired percentage that could be used for the solution. This will have an effect on the impact of the strategies. In the next step is to draw implementations of the solution. This map shows actors that generate coffee grounds in the city of Amsterdam and outside. Restaurants, hotels, catering, as shown here in these legends. This is the basis for drawing implementations of the solution bio-beam. Using the GDSE, participants can draw multiple implementations of the same solution and also of other solutions that are part of the integrated strategy to develop the circular economy of their city. The GDSE selects those actors and activities that produce the specific waste flow. The GDSE then assesses all the strategies that were drawn by the small groups, both in terms of sustainability and circularity. The flows and actors that are inside a drawn polygon are incorporated in the calculations to modify the flow situation and thereby reduce quantities of waste. Multiple solutions can be selected and locations of implementations can be drawn using the GDSE. Once the small group finishes drawing implementations, the next step is to press the Calculate button. The GDSE will start assessing the impact of the strategy on the waste and material flows of the status quo. But how is this impact actually calculated? Solutions are modeled as a collection of solution parts. A solution part describes a proposed process looking to affect a current process. This is status quo flows between economic activities. A solution part is defined as 6 different schemes shown on this slide here. For example, the first highlighted scheme shows a solution that modifies the masses or quantities of flows. The second and third schemes show shifts of origins or destinations spatially, and the fourth scheme adds a new flow to the system. The drawn implementation areas capture actors. Flows between economic activities are redistributed. The algorithm of the GDSE keeps the overall mass balance of the affected flows consistent, and it also distributes total surplus or shortfalls within an economic activity in between all actors inside the drawn implementation area. Then flow changes are reflected in the chosen flow indicators, and their values can be compared with the targets that were set up earlier. Now, let's look at some eco-innovative strategies developed in the peri-urban living labs of the case studies of REPAiR. This is an example of locations drawn for a solution called Robots by 6 small groups representing industry, government, and research at a peri-urban living lab workshop with stakeholders of the Amsterdam metropolitan area. The flow assessment screen is used to show the results of the assessment of the strategies. In this screen of the step strategy, members of the small group view the impact of the strategies on selected flows of the status quo. Let's look at the Sankey diagram. Flows are now colored to denote impacts. Flows in red show reduced quantities of materials waste in the flow, while green flows show increased quantities of materials and waste. This flow view shows the new attributes of the flow on mouse hovering 2. This is an example of locations drawn for Naples. It's an example of 3 solution implementations proposed from Ghent, Belgium. These are drawn locations for Hamburg. And these are solution implementations in Pech, Hungary. The final GDSE step, called Conclusions, presents, compares, and supports the discussion of the entire group of participants in a plenary session. This step involves 6 separate screens, each of which is used to compare the work of the small groups. Here we can see how the GDSE presents a comparison of how the groups ranked and prioritized the circular economy objectives. We see 5 small groups representing industry, governance, and research organizations as an example of a peri-urban living lab small group configuration. This screen shows a comparison of how the targets were set, and to what extent the goals were met by the strategies developed by the small groups. The GDSE also determines which solutions were used or selected the most by the small groups, presenting a comparison of the solution usage. The locations of all solutions are also shown per solution. This can be potentially interesting to identify synergies and areas for further collaboration. The GDSE also determines which stakeholders were selected the most and also the least for further involvement in the development of the strategies. And finally, the GDSE shows a comparison of the effects of the strategies on the existing flows of waste. For example, the bio-bean solution may have impact on the flows of coffee grounds in the form of a decrease by a certain percentage, thus contributing to a reduced waste quantities and a more circular economy. And with this, I end this presentation. Thank you very much for your attention. And for more information on the GDSE, I leave a link here, more information on the software. Thank you.
Really, thank you so much, Gustavo, for your very interesting presentation. And now I give the floor to Alexander Wandel, that is also the coordinator of the panel discussion that followed. Thank you so much.
Thank you, Maria. Thank you to the presenters. Carl and Dirk, you should have now on the top right share video or share video and audio, so you can join. Pressing this. Yeah, Carl is here, and Dirk, you should have the same option for the joining in. Good. So now that we are complete on the panel, I hope Dirk is also managing it in a minute. Again, thank you for the presentation. I have 3 topics I think that are interesting to discuss, and I would like, and there were 1 or 2 questions in the chat. I would like to start though with the non-REPAiR members, so with Julia, Dirk, and Michele. The 3 issues that I wrote down that are interesting for me is one is the discussion about land use. A land use way of approaching cities and territories, and the urban metabolism way of approaching territories and cities. I think that is one that is absolutely interesting. The other one is the strategic design and systems design, or systemic design, I would say. It's a different design, which is interesting. And the 3rd one is optimization and disruption. So I think that was kind of, if I may throw a little bit some hints to the discussion, and then ask Julia, please, to reflect as a first, as an external on what you have been hearing today and now.
Yes, thank you, Alexander. Do you hear me? Yes, everybody? Okay. Well, first of all, thank you for inviting me to this conference, because the presentation in the morning and now are really interesting, and the project, I think, that give us a lot of suggestions for the future, and give me the possibility to reflect also with our project Urban Wins, where we study circular economy on the territory, but from a different perspective. And I think that your approach of planning and land use is very interesting. And I have also some questions for you, because reflecting on the way on which the people that live there can give you suggestions, and the use on which you map the flow is very useful, I think, to discuss with the population and give them the real dimension, maybe, of the waste and of the problem that they have. Because, for example, one of the main problems that we had in our participation group that we call Agora, that are not really living labs, but are similar from some aspects, the most difficult thing was give the real dimension of the problem sometimes, because many times they don't really understand which are the mass and the dimension of some flow, the dimension of some problems that they have, and understand their perception of the problem that many times is very different from what our data are, and so our different idea of solution. So for me, it's very interesting the way I understand really well the way in which you translate all the data, all the flow that you have, and some interesting mapping that you show, and in which way in the pools, in the living lab that you have really work on that, and in which way they use this data, these maps, to elaborate the solution, the co-created solution, which are the links they make between the flow, the diagram that you elaborate, with the real solution that then they elaborate. I don't know if it's clear, because I think that that is a very interesting point for all of us that work with data and with the population at the same time, because for us is one of the main gap that we have.
Thank you, Julia. I think I'll ask then after the first short round, Libera,
Yes.
Maria, Annie, and Gustavo to answer that, because I think it's a very valuable question. I have also a personal answer on that. That is, I can share them as well. And I'd like to have Dirk.
Yeah.
Give his,
Thank you, Alexander. Thank you. Hello, everyone. And it was great to join and follow the session. Interesting presentations, and actually focusing also on land use in the presentation of Karl Steinitz, at least recognizably some of the more land use oriented geodesign tool applications. And I thought in the total perspective of REPAiR, it's a very nice, let's say, complementarity has been reached between addressing land use and the topic of metabolism simultaneously, or showing basically the two sides of this coin, and where probably many of us are used to look at maps and geomaps to a certain degree. We still look differently at it than a layperson, that's true. But the topic of metabolism and streams of resources is, I think, also new to many of us. Or at least it's, I think, a little bit, one can consider it as a breakthrough, because it has been a handicap, I think, in our resource management profession to properly document and demonstrate what actually resource streams means. And I mean, the presentation which Gustavo has given showed, still, of course, abstractions of this. And but these abstractions are based on true volumes, and I think that type of presentation can give some insight, some feeling about what actually is going on. So we see it now with the pandemic and the virus cases. If you look outside the window, it seems like nothing has changed, and but in fact, lots of things have changed, and this is very similar with metabolism. We have invisible streams and invisible, let's say, use of resources, which so far has only reached basically numerical table style and statistical qualities. And so I really think working together with stakeholders and looking at these types of abstractions of flows is a very helpful thing to do. So that's something on. That doesn't diminish the role of land use, of course, but I think it really adds to the dimension, the true dimension of environmental processes tremendously. So I would like to congratulate the REPAiR team in this respect. And of course, it's nice to see that this is embedded in strategic thinking and in co-design development, which involves people, which lets them, deal with the data, play with the data. I think that's exactly what we also do, in projects where I'm working in, which are related to food traffic, food transport, but also circular economy. I can tell you one of the aspects is, that the reuse of agricultural production in terms of biomass, higher value chains for biomass, is certainly an upcoming issue where we look at land use, but we at the same time need to have, let's say, techniques and tools how to assess, the waste streams which are linked to this. So these are the streams related to the agriculture products, at the same time to the waste streams. And there was a nice example in Gustavo's presentation, which showed the kind of coffee waste stream and the different operations. Now there are many different ones. This is just one example, but I know, for example, about, and we had discussed this with Gustavo, there is an example about, you probably know that from coffee waste you can also produce mushrooms and other, let's say, restaurant goods from just on the basis of the coffee waste. And that would be another one. And so you can see different type of value chains unfolding around a certain biomass good. And to show this to people who have to make decisions or have to make maybe their business from it and find the appropriate streams is just a great tool to work with, I think.
Okay. Thank you, Dirk, and also thank you for specifically pointing out, I think, this supplementarity of the two approaches, which I would agree completely with. Michele, please, I would be very interested as you're and one of the closest collaborators with Carl. So really interested in your feedback. You're muted, I think.
I found it very interesting. And
no, I don't hear you.
Well, we hear you.
Now you should work. Now it should work.
Can you hear me?
Yes.
Yeah, okay. No, I'm very glad to be here. Thank you for inviting me. And I think this session is very interesting. And it made me reflect a lot about seeing different application of the geodesign framework, how the geodesign framework, the science framework, how general it is to be applied in many different contexts. And one way doesn't exclude the other, thanks to the level of interoperability in technology that we nowadays have. And Carl did mention that in several experiences, the workflow and of geodesign implemented in Geodesign Hub was easily connected to other workflows, integrating different models, exchanging data, so that working at the strategy level can at the same time integrate work in a different, more specialized level. What we did together in the first Cagliari case study was to connect to other planning support, Geodesign Hub with other planning support system, and take the data from Geodesign Hub and applying a more sophisticated impact model, for example, done with a more powerful GIS software. And this exchange can be done. And the framework, the power of the framework, Carl said that there are many frameworks. Important is to use a framework, but I believe the science framework is, in my experience, so general that really can be flexibly applied to all levels, in research, in education, and in the practice. And in my experience, in all the three cases, there are always two main benefits. The first one, that all the involved stakeholders improve their knowledge and their understanding of the often very complex issues they deal with. And in many times, especially working in more practical applications, often we end up with influencing political decision. And this is my experience with a group of municipalities last year. In a similar fashion than Carl explained, we work for not 8, but let's say 15, 16 hours with 5 mayors, with the technical staff, but also involving stakeholders from the community, from the private sector, and scientific institution. And eventually the result, again, in our case at the strategic level, are going to be put in a policy, in a real policy. And another great benefit that I noticed is then when we involved the stakeholder at the very beginning of the process, they were very suspicious. but working with the same language, with the same platform, everybody could really play the same game. And eventually, at the end of the workshop, everybody agreed, and they were happy. They changed, really, their face changed. So it was very beneficial experience from everybody. And to conclude my observation, my notes, I would like to mention that how important it is, again, to have a framework, and to, I think it's very difficult to involve many people without a very structured workflow arranged beforehand. What I call the meta planning, the design of the process. It is very important because there is no space. If you leave space for unstructured work, often in real life, especially in southern countries, people just start doing other things and lose track. So having a framework, defining very well a workflow, that actually is the second iteration in the science framework. It's called in a different way, but this is what it is, really help to deal with big numbers of people, let everybody have their say, and eventually being happy in produce a constructive work. And again, this can be done plugging together different workflow, a different scale, with different level of granularity in our investigation. And my experience is it is always beneficial. And the examples we saw today, I think, contribute to demonstrate this.
Thank you, Michele, for this statement and to the point comment. I think it was also really good to see in our process that it was in two things very flexible, the framework. First of all, internally to work as a interdisciplinary, sometimes even transdisciplinary team, so that helped as well. And then indeed, if in allowing people to participate, that is very, very crucial. Carl, I have a question from the audience, which I'd like to join in now in the discussion. Maxim Amosov is asking, while your presentation, what are the points of negotiation among the design teams? Are they on the level of infrastructural elements in the system, their individual or shared performance as a system, or the impact of the entire scenario?
That's not his whole question.
And indeed, and how optimization?
And furthermore, he assumes that one design makes the others void. That's a major error. He obviously missed my first slide. My first slide says that the process should not result in a zero-sum game. Period. The process of negotiation is first, system by system in the rank order of importance, so that two teams which have different rank orders alternate choosing. And we have a mechanism for saying who goes first. So I'm going to deal with water. Kaylee's going to do with agriculture. It's his choice. Then I'm going to do with high density housing. He's going to deal with transportation. Then we step back. We look at, as we build the thing, because we're not looking at the whole design. We're building it, looking at the whole design. Then we step back and we say, have we finished? No, that's a mistake. Make that road 15 kilometers further out. Redesign it, put in a new diagram. You think that's better? Me too. Finished, finished. Thank you very much. Everybody, is it better than it was before? Yes, 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 yes. No, yes, yes. No, yes. That's good enough. Stop. That's how it, there is no concept called optimization because you have a multi-dimensional, multi-decision model process. There cannot be an optimization, which, by the way, is a very important lesson. Just because you have software that can do an optimization doesn't mean it works.
Yeah, I think that is one of the key messages also from our side, that the, let's say, circular economy is in its beginnings very often optimization driven, and it's not well, it's not leading to a real system change. Yeah.
One of the interesting things is that I don't think that the work at the two extremes, this is comment to Dirk, is complementary until it becomes complementary. For example, everything that I've seen this morning and this afternoon with respect is really useful for managing the half-life of the data that went into it. But unless you have real-time data as input, it won't work, because the obsolescence and the variance over a yearly long cycle of the inputs is enormous. So one set of numbers producing a very complicated graphic solution, which, by the way, is too complicated, doesn't let the prime minister or the mayor actually know what to do. It lets companies using it for their own purpose do it, and that's useful. No mistake, that's useful. Furthermore, if there's disruption to the assumptions at all, like the systems of production are changing from the producers, the model is valid, but the output isn't. And you have no way at this point of updating or varying internally in a regular way the input data. Furthermore, if you have my and Michele's final design and say, I want to have a circular economy, tell me what to do with the waste, you need to realize that half the people that are there now won't be there in 30 years. Those people don't exist yet, and half the people who are now consuming and producing will be dead. So how do you take my design and put it into your model? That's what you need to do, or recognize that it's a short half-life for the output. But that's useful. Nobody's arguing that. It's really useful. You're the coronavirus team. You're not the health system for the year 2050.
No, indeed.
That's really important.
Yeah, indeed. Absolutely. Thank you for that input. I'm giving now the word to the REPAiR team sitting in the room. We have another 5 minutes. Then we have to leave to the short break and to the plenary session and the final discussion. So, Maria, perhaps you want to be the first to respond back to a certain extent.
Thank you so much. Really sorry because there is a sound and I am not able to stop. And really thank you for your interesting observation, especially because I think that the topic of negotiation is particularly relevant, especially for a concept that we tried to face in the REPAiR project, starting from the idea that a transformative design needed to be co-created according to the site-specific issue. So we started from reality, and the different reality of two main pilot cases, especially Amsterdam and Naples, are really different as case study, but are very interesting because they were the context where we identified some issue, able to understand in which way we could like to manage the conflict, different kind of conflict, in order to select some enabling context for activate the change. And the definition of the enable context is particularly interesting because it's the way where the point of view of the different stakeholders, but also the relevant information that different kind of data can offer can be mixed, and where we can activate the interaction between the subjective perception of the problems and objective definition of the problems. That could be really interesting to identify as opportunity for identify the change, and also construct some opportunities for manage the transformation. So in this way, we think that we are able to work again, especially in the next future together. So really, thank you.
one of our colleagues was just posting in something clarifying clearly, and I think that's important to say that GDSE is not optimizing strategies. It provides a common ground for co-creating strategies, gives participation an idea of what the impact on the strategy of the flow may be. So I think that's also important. So that's something we clearly share to each other. Final last words from Gustavo, Annie, Libera. Gustavo,
I can go further on Jens Martin's point, which I think is crucial that he makes this point, clarifying that the GDSE is actually a research tool that supports the process and informs decision making and the negotiations involved in it, and not an optimizing model. And what we try to do is just try to transform complex informational flows that already comes from a very complex process to arrive at these flows and also strategies, and try to convey it in a way that can prompt and stimulate a dynamic discussion between stakeholders that participate in a workshop and they want to make decisions on future paths for towards a circular economy. So I believe negotiation needs to be important, and I also agree that the GDSE is not an optimization model.
Okay. Good. Libera, some last.
I just wanted to respond quickly to Julia's question. If I understand well, she asked how we link the geodesign framework, the mapping exercise, and the developing of solutions and strategies. And I just would like to summarize with one or two words. So iterative process. So for us, everything was done in an iterative process and through a learning by process. And so this is our spirit of the pool carried out in REPAiR. This is what I wanted to add.
That would be nearly famous last words. But Annie, I want to give you also the possibility to.
I perfectly agree with the Libera, and I'm also noticing that in a sense all the discussions were talking with the similar concepts. I heard different words, but they were all put the data on the table, making them visible, improving knowledge. So I think that in this sense, I think that our message went far from our own presentation and came into this panel, and I think that it was really interesting in this sense.
Okay, good. Thank you very much. Then it's my pleasure to thank you all for your contribution to the discussion. I enjoyed it a lot. I think it's we could spend another 2-3 minimum hours to go into the details. I also want to thank the audience for staying with us so long. So it's around 50 people still watching. So it's good to see. And I hope to see you in 10 minutes at 4 o'clock Central European time on the stage, so in the plenary session. Goodbye, everybody.
Thank you very much.
Thanks a lot.
Thank you.
Bye.
Bye.
Thank you.